everybody. When they get this PowerPoint working. There we go. Hi, everybody. I'm Bjorn Mellem, and I'm here to talk to you about human space exploration. Now, today, the population of Earth is about 7 billion people. By contrast, the population of space is 6. That's the crew at the International Space Station. Now, we've had some successes in space, but lately it's been stories about the things that have not worked out so well. Things like 40 years ago when we went to the moon with the Saturn V rocket and then stopped going back there. Things like the Space Shuttle that was canceled last summer, and its replacement, the Constellation project and the Ares rocket, that were also canceled in 2009 due to budget overruns and a lack of funding at NASA. We don't have any of these things anymore, so why am I here talking about human space exploration? Well, where do I come in here? I've had some work in space. I'm obviously not one of the 6 people I showed you that's the population of space. I'm right here. But I have worked with the SETI Institute, the Search for Extraterrestrial Intelligence, and NASA at the NASA Ames Research Center down in Mountain View, California, where I got a bit of involvement and exposure to the field of space exploration, and a little bit to human space exploration as well. Now, when people think of SETI, they think of this. This is the Allen Telescope Array. It's constantly searching the stars, listening for radio signals, listening for ET calling us. But that's not the only thing that SETI does, and that's not what I did when I was there. Instead, I worked at the Carl Sagan Center for the Study of Life in the Universe. And what the Carl Sagan Center does is studies anything remotely related to the possibility of life elsewhere, from looking at chemical reactions that might indicate the presence of life in the soil on another planet, to looking at extreme life forms here on Earth that can survive in situations that we might find elsewhere in the solar system or elsewhere in the universe, to looking at the climates of other planets. And that's where I came in. Last summer, I worked at SETI as a climate researcher working on the North Pole of Mars, which I show right there. What we were interested in was how the North Pole of Mars thaws during the spring. To give you a little bit of information about that, the North Pole of Mars has 2 different types of ice on it. Regular water ice, like what's on our North Pole here, and carbon dioxide ice, dry ice. It gets down to minus 200 degrees Celsius over the pole of Mars, and the atmosphere of Mars itself, which is made of carbon dioxide, freezes onto the ground to become this layer of ice. And we were interested in discovering some of the processes about how that ice on the North Pole forms and thaws. To do that, we used the NASA Ames Mars Global Climate Model. And this is actually a climate model that is also used here on Earth to model the possible effects of climate change and global warming. We can see clear environmental benefits to going out into space and looking at things in space. Environmental benefits here on Earth. Things like trying to perfect the Mars Global Climate Model in order to help our understanding of how the climate works on Earth. If we can send people into space, maybe we won't have an overpopulation problem in a few years. We have 7 billion here and only 6 there. Maybe there's a bit of an imbalance we should address. And if we can send people into space and send possibly our wasteful products, pollution, side effects of manufacturing processes, there's a lot that could be given back to the Earth by sending these things out into space. So there are a lot of other benefits to taking people and sending them out into space as well. One of them is international cooperation. There is nothing that would bring the world together like that. At least I hope there's nothing that would bring the world together like that. International cooperation in the face of a terrible disaster like the potential for an asteroid hitting Earth would certainly be an extreme way of getting people into space. But any attempt to get people into space, I believe, will require a lot of international cooperation. We have a lot of treaties and agreements in the United Nations and elsewhere about how we should treat space, and we have some ideas about its scientific uses, things like a protocol called the Planetary Protection Protocol, which is designed to keep us from polluting places like the Moon or Mars, where we might be interested in using those as clean environments for labs and experiments. And it'll require international cooperation to figure out how we're going to deal with those issues as we go into space. It'll require international cooperation to colonize the Moon and to colonize Mars. So a lot of people see asteroids this way, but some people see asteroids more like that, a big flying gem out in the cosmos, waiting for somebody to come and mine it. Economic benefits of going to space could be enormous. Peter Diamandis gave a TED Talk several years ago about his goal of going out and expanding the economic sphere of human activities to include mining in space. There are trillions of dollars of raw materials available in asteroids, where heavy metals and other elements that fell into the core of the Earth during its formation are readily exposed on the surface. And people think that many of these asteroids may be impacting places like the Moon and leaving deposits there which we could go and mine. Speaking of people who might want to visit the Moon and mine there, this man is Bob Richards, the CEO of Moon Express. Moon Express is one of a series of private space enterprises which I believe will be opening up the new age of human space exploration in the years to come. I met Bob Richards over the summer when he visited the SETI Institute to speak about his work and his goal of winning the Google Lunar X Prize. His goal is to put that robot on the Moon by 2015. When I look at his timeline and I compare it to what NASA is talking about, with maybe going to an asteroid around 2025, 2030, I think this guy might be able to do better. And there are other people working on this as well. There are many people, many companies involved in competition now for the first time to try to open up space on a commercial and industrial level. People like Bill Stone. Bill Stone is an adventurer. Bill Stone began his work in caving. He was a spelunker and explores underwater caves for a living. He builds equipment like this, DepthX, a robot designed to explore underwater in caves. And he discovered that much of the same technology that's used underwater in caves can be applied to go to the Moon and explore there and look for water on the Moon. Bill Stone not only wants to put a robot on the Moon by 2015, he thinks he can go there by 2015 and find water. He might take a bit of an extreme approach. He wants to go to the Moon without enough fuel to get back and find the fuel to get back. Now, maybe not many of you would sign up for his journey, but he thinks he can do it. And he's not alone in thinking that this might be a possibility. He's got a company that's working actively to try to make this a reality in just a few years. And I'd be remiss not to mention this man, Elon Musk of SpaceX. In little more than a week from Tuesday, in fact, he plans to become the first person to put a rocket into space to dock with the International Space Station. He's already made SpaceX the first private space corporation to successfully put a capsule in orbit, send it in orbit around the Earth, and then retrieve it safely. And this is his rocket, the Falcon 9. It carries the Dragon capsule up to orbit and hopefully beyond. He's designing another rocket, the Falcon 9 Heavy, which will be capable of launching large payloads to the Moon, Mars, or even beyond. So, private space corporations are initiating a new space race, a new competition. At one point, it was a space race between the US and Russia, and there was a time when Russia was winning. But the Soviets never really looked at space exploration as a race. They viewed it as building a road to the stars. And I think that's the way we should start looking at it as well. So I invite you to, in whatever way you can, help us build a road to the stars. Thank you.